Okay, so this is just a little video going through that Kirchoff's law question, because I know some of you are still struggling with your loop equations. So as it says in the question, the easiest way to do this, we're only going around the loop A, B, E and F here. So the easiest way to do this is make sure that you're putting the high and low on each component, and then draw a line showing where you're going to go around the circuit. So this is given to us in terms of conventional current flow here. Okay, now in your notes we're looking at electron flow. So your electron flow will be in this direction, coming down here, your electron flow will be in this direction. So what we've got to work out is which is the high and the low side of everything. So we've got negative and positive on our battery here, like this. So if you go back and have a look at your notes, when you're labelling things, there's a high side and a low side to everything. So what we've got to think of here is which is going to be our high and our low side. Okay. So as our electrons are leaving, they're going to be leaving the negative side, they're going to have high energy. And when they get back to the battery, they're going to have low energy, which will be the other side here. Okay. Now, when we're looking at what's the high and the low side of the resistor, you see we've got to think about where our electrons are flowing. Okay. So if our electrons are flowing in this direction, electrons are going to lose energy as they go through the resistor. So we're going to have high and low here. And as our electrons are coming around in this direction, high to low. Okay, because that's the way our electrons are flowing. Okay, so it asked us in the equation to draw a line showing your loop starting at A. So it doesn't matter which way round the loop you're going to go, but it's a good idea just to show which way you're going to go around. I'm going to go around clockwise, okay, because that makes more sense to me. So in my equation, the first thing that I'm going to get to is the resistor. So we're walking past the resistor in the same direction as the electron flow, so that's going to give us a voltage drop. Okay, so we've got a current of I1 and we've got 3 ohms. So we've got I1 multiplied by 3, the voltage drop, so it's going to be negative. Okay, and then we're going to come round to the battery. So if we think about the battery is pushing electrons out of the negative end, and so our negative is always the high side. If we're walking past the battery in the opposite direction that it's pushing, then we get a voltage drop. Okay, so if we're thinking about which way it's going to push, okay, we're going to be pushing high to low. Okay, so that's how we're going to give energy. So as we come round here, we're going to be going through our 9-volt battery. Okay, we're going with the electron flow, it's going low to high, so we're going to be gaining voltage, so we're going to have positive 9 going through there. As we go through our 2 ohm resistor, we're going from high to low, so our low to our 2 ohm resistor, so we're going to be again losing energy as we go through here. This time we've got the current is the 1.2 amps, and that's going to be multiplied by our 2 ohms. I'll just put those in brackets. Now as we come up to the 4-volt battery, we are going this time from high to low, so as we go from high to low, that's going to be a voltage drop as well, so we're going to have minus 4 volts in there, and that's all going to be equal to 0 because we're back to our starting point. So I think with these questions, as long as you label the high to low, think about which way you're going. Are you going with the electron flow, or are you going against it? Where are you going to gain energy, where are you going to lose energy as you're going around the loop? It's fairly difficult, I guess, at that point to get those questions incorrect. If you did want to do this in terms of conventional current, because a lot of the time your conventional current is going to be what's given to you on the diagram, sometimes that's easy. I'll go through that and show you how you get the same answer in red. So obviously conventional current is already given to us on this diagram. So if we think about conventional current here, as we go through our 3 ohm resistor, we would expect to lose energy as the current goes through it. When we come around here, we are going to have our battery. Now this is the positive side of the battery, this is the negative side of the battery, so we know that current is going to be flowing around here, and as it goes through this 4-volt battery, okay, we're going to be going from the positive to the negative. Okay, so that's kind of, I guess, going with our current flow. So this time, if we're thinking about in terms of conventional current, we're going to have a high and a low side here. And again with this one, we're going conventional current here, so high to low, we'd expect to lose energy as we go across here. And again here we're going to have low to high as we go through the 9-volt battery. So if we're writing our loop equation now, as we're going through here, we're going to be coming up here, we're going high to low still, even that because we're going with conventional current this time. So we're still going to have minus times by 3. Excuse me. Okay, so this time low to high, but we're going against the current this time, so we still end up with a negative here. As we come around the loop again, we're going against the flow of current. Okay, so we're going against the flow of current, and we're going low to high this time. So as we go from low energy to high energy, we're going to gain that. And then here we're going low to high as we go through this one, but we're going low to high and we're going against the current. So we're going in the opposite direction to our current flow this time. But we are also going low to high, and so we get a voltage drop. And here again we're going against conventional current flow, and we're going low to high this time. So if we're going low to high and we're going against the flow of current, you get a negative voltage here. So either way you'll still get to the same answer, but the pencil way is following the way that you're shown in your notes.